EmerNeRF, Emergent Spatial-Temporal Scene Decomposition via Self-Supervision. We present EmerNeRF, a simple yet powerful approach for learning spatial-temporal representations of dynamic driving scenes. Grounded in neural fields, EmerNeRF simultaneously captures scene geometry, appearance, motion, and semantics via self-bootstrapping. EmerNeRF hinges upon two core components. First, it stratifies scenes into static and dynamic fields. This decomposition emerges purely from self-supervision, enabling our model to learn from general in-the-wild data sources. Second, EmerNeRF parameterizes an induced flow field from the dynamic field and uses this flow field to further aggregate multi-frame features, amplifying the rendering precision of dynamic objects. Coupling these three fields, static, dynamic, and flow, enables EmerNeRF to represent highly dynamic scenes self-sufficiently, without relying on ground truth object annotations or pre-trained models for dynamic object segmentation or optical flow estimation. Our method achieves state-of-the-art performance in sensor simulation, significantly outperforming previous methods when reconstructing static, plus 2.93 peak signal-to-noise ratio, and dynamic, plus 3.70 peak signal-to-noise ratio scenes. In addition, to bolster EmerNeRF's semantic generalization, we lift 2D visual foundation model features into 4D spacetime and address a general positional bias in modern transformers, significantly boosting 3D perception performance. For example, 37.50% relative improvement in occupancy prediction accuracy on average. Finally, we construct a diverse and challenging 120-sequence dataset to benchmark neural fields under extreme and highly dynamic settings. FLAP, Fast Language Audio Pre-Training. We propose Fast Language Audio Pre-Training, FLAP, a self-supervised approach that efficiently and effectively learns aligned audio and language representations through masking, contrastive learning, and reconstruction. For efficiency, FLAP randomly drops audio spectrogram tokens, focusing solely on the remaining ones for self-supervision. Through intermodal contrastive learning, FLAP learns to align paired audio and text representations in a shared latent space. Notably, FLAP leverages multiple augmented views via masking for intermodal contrast and learns to reconstruct the masked portion of audio tokens. Moreover, FLAP leverages large language models, LLMs, to augment the text inputs, contributing to improved performance. These approaches lead to more robust and informative audio-text representations, enabling FLAP to achieve state-of-the-art SOTA performance on audio-text retrieval tasks on audio caps, achieving 53.0% R at 1, and Clotho, achieving 25.5% R at 1. PPTC benchmark, evaluating large language models for PowerPoint task completion. Recent evaluations of large language models, LLMs, have centered around testing their zero-shot/few-shot capabilities for basic natural language tasks and their ability to translate instructions into tool APIs. However, the evaluation of LLMs utilizing complex tools to finish multi-turn, multimodal instructions in a complex multimodal environment has not been investigated. To address this gap, we introduce the PowerPoint Task Completion PPTC benchmark to assess LLM's ability to create and edit PPT files based on user instructions. It contains 279 multi-turn sessions covering diverse topics and hundreds of instructions involving multimodal operations. We also propose the PPTX match evaluation system that evaluates if LLMs finish the instruction based on the prediction file rather than the label API sequence. Thus, it supports various LLM-generated API sequences. We measure 3 closed LLMs and 6 open-source LLMs. The results show that GPT-4 outperforms other LLMs with 75.1% accuracy in single-turn dialogue testing, but faces challenges in completing entire sessions, achieving just 6% session accuracy. We find 3 main error causes in our benchmark: error accumulation in the multi-turn session, long PPT template processing, and multimodality perception. These pose great challenges for future LLM and agent systems. We release the data code and evaluation system of PPTC at the project's website.